Today we're going to look at properties of operations. This is lesson 3 in chapter 5, and this is page 367 in your book. So in our first lesson for this chapter, we looked at algebraic expressions, expressions that include numbers, operations, and variables. And we're going to look at some properties that go along with our addition, our subtraction, our multiplication, and our division, and that we can use with our algebraic expressions. So let's start with a real-world link here. This deals with driving down the street, which I'm sure all of you have done, well, as a passenger. But Miss Ricardo drives up and down her street to complete the different errands. Some of the places on her street are shown below. The number of blocks between the places are also shown. Number 1. Suppose Miss Ricardo drives from home to the game store and back. Write an expression for each distance. All right, so let's start with home to the game store. So you can see home is on the left. She has to go 2 blocks to the library and then 1 more to the game store. So that's 2 plus 1. And then she wants to go from the game store home. So she's going to start at the game store. She's got to go 1 block to the library and then 2 more blocks home. So that's 1 plus 2. Now the property for this is your commutative property. And that just states that when you switch your numbers or your variables with addition, you will get the same sum. It also works for multiplication. It does not work for subtraction or division. All right, so then on Monday, Miss Ricardo drives from home to, she's going to stop at the library. So home, stops at the library, and then drives to the football field. So let's start with Monday. Home, stops at the library, so that's 2. And then drives to the football game. Well, to get to the football game, she's got to go 1 block to the game store, 3 more blocks to the football game. So that would be 1 plus 3, or a total of 4. On Tuesday, she drives from home, stops at the game store. So if we go home to the game store, that was our 2 plus 1 that she did all together. And then went to the football field, which is 3 more. So if you notice, same order, 2 plus 1 plus 3, or 2 plus 1 plus 3. Okay, so same order, 2, 1, 3, but our groupings were different. She did different she drove through at different times. This is an example of the associative property. You can change your groupings in addition and multiplication and still get the same sum or product. Okay, so I just discussed commutative property with you, associative property with you. Down here are 3 others. Identity property, you have 2 of those. Additive identity is when you add 0 to any number and you notice you keep the same number. It's like you have your identity. If we added 0 to you, you'd still be yourself. Multiplicative is if we times a number or a variable by 1, it stays the same. Same with you. We could times you by 1 and you would stay the same. And finally, the multiplicative property of 0. This is if we times a number or a variable by 0, you get 0. So down here at the bottom, they want you to name the properties shown by each statement. So if you look at the first one here, letter A, we have 42, Y, and X. But if you notice right here, they flip-flop the X and the Y. So that's an example of the commutative property of addition. You would get the same sum, they're just flip-flopped. And then B, notice we're adding a 0, and it stays 3x. So that was one of the ones in our chart up here. That's the additive identity. If we add 0 to a number, it stays the same. All right, so once you know your properties pretty well, you can figure out whether a statement is true or false based on your properties. And if it's false, you can always provide a counter example. And this is just an example that shows that a conjecture or a statement is false, meaning the property does not apply. So you've done true or false before, and it says if false, explain why or prove that it's false. That's what a counterexample is. So in number 2 here, it says division of whole numbers is commutative. Remember, commutative is our one that we can flip-flop and get the same answer. But notice for division here, 15 divided by 3 is 5. But when you do 3 divided by 15, you get 1/5. So this is the counterexample right here. It's proving that it's false. All right, so if we look at letter C there, this is asking us to true or false, okay? The difference, meaning subtraction of two whole numbers, is always less than both of the two numbers. And this is going to be false. And our counterexample, there's many counterexamples. The one I can think of off the top of my head, 8 minus 2 is equal to 6. Well, 8 minus 2 is 6. All right, is 6 less than both of the two numbers? Well, it's less than 8, but it's not less than 2. So there's a counterexample. All right, so you can use these properties to simplify your algebraic expressions, your numerical expressions. So if you look at the example here, number 3, Elena wants to buy a sweater that costs $38, sunglasses that are $14, jeans that are $22, and a t-shirt that's $16. So here's your addition problem. All right, but you could use mental math to add this simpler, to make it simpler. So 38 and 22 are pretty easy to add together. So you would use the commutative property to flip-flop these two, actually not the 38, but you would flip-flop the 14 and the 22 so that the 22 is closer to 38. And then you could add the 38 and 22 together. That's going to give you 60. And when you flip-flopped the 14, all right, the 14 and the 16 were closer together. All right, so that you could add those together and get 30. Now, the associative property of addition also plays in here because we group the 38 and the 22 to add together, and we group the 14 and the 16 together. So this is just basically helping you prove why you're doing each step. Why can you move addition problems all around? Well, because of the commutative property. Why can you group certain numbers together in an addition problem? Well, because of the associative property. All right, and then the last part here is just an example of what I just said. If you look at letter E on the next page, all right, in this problem, okay, you can multiply all three numbers together, actually, and the variable. But you would probably start with the 4 and the 2. So you'd want to flip-flop these two so that the 2 is closer to the 4. And then your parentheses are around the 3C and the 2. But like I said, you'd probably want to do those two first. So we could move the parentheses around the 4 and the 2, and that's the associative property. So that gives you 8 times 3C. You can multiply things that aren't the same. So 8 times 3 is 24 with the C.